Welcome to today's webinar. The topic today is selected concrete features in Rfem 6. We will introduce you useful features, also new features that we implemented in the last months. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the German and English webinars, technical content of the website, newsletters, customer projects, and so on. I will be the moderator today, and I will answer your questions during the webinar. And my colleague, Richard Hase, will be the presenter for today's webinar. He is responsible for customer support and also for product engineering. And in the product engineering, for example, for the add-on concrete design. And as I said, he will do the presentation today. Some words from my side, how you can ask questions. At first, I switch off my camera that you can see the full screen. Just press that button with the question mark, then enter your question here, press send, and I will receive your question and I will answer you. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, that's all from my side. I hand over to Richard. Richard, it's your turn.
Yeah, hello from my side. Thank you, Andreas, for your introduction. And short to me, I'm Richard Hase, and how Andreas tell you, I work for Dlubal in the customer support and work in the product engineering for the concrete. And I will show you now our points for this webinar. At first, I will show you some points of the reinforcement layout for surfaces, special and automatic function. The next point is fire resistance design is at the time a simplified method by tables, and for columns we have a fire duration equation. In future will come more, but that's another point. But now I will show you this simplified method we have at the time for you. The next capital, it's relative new. Our punching shear reinforcement. We have now in the program the option to define and modeling punching shear reinforcement. Before this feature, we only able to give the forces and parameter for reinforcement from other firms or so, and now we can modeling this reinforcement type, and you can calculate complete with Rfem 6 your punching shear design. After this, I will tell you some about the SLS design, deflection and steel stress, and also come to the effects of creep, shrinkage, and tension stiffening. But to that, I would tell you later. And the last point is the fatigue design. There we have at the time two alternative design options. I will come to this later. Okay. Good, then let's switch to Rfem 6. No, sorry. Let's come to the reinforcement layout. Sorry. So first I will show you the different location types. So you have the option to define reinforcement for a whole surface, or you're able to define some reinforcement, for example, in a rectangular form. So it is in a limited area you can define different reinforcement sizes. Yeah. Then another feature I will show you is to, froze the results. I will show you, then you will understand better. And yeah, to the automatic function for reinforcement. So here in this picture you see is also normal. There you can choose the diameter of the rebars, and now you're able to set an automatic function, and Rfem will calculate the required size of these rebars at the place. But I show you also better with the model. Okay, then now let's really switch to Rfem 6. It's two-story building, simple building with here some cantilever. The materials also normal, so normal concrete and concrete steel, so nothing new and spectacular. And important for this webinar is that you have activated in the space data in the add-ons the concrete design. All these features I will show you need to activate this design add-on. And for the fire resistance, I also, so it's an additional point, but I will show you that there is a connection, the building model add-on, because in the building model add-on it is possible to define shear walls and deep beams. And it's a simplified way to define this objects. If you don't use the building model, you must create, for example, the shear walls and deep beams via result beams. So building model have a lot of other features, but I will show you this fact for the fire resistance. Okay. But then let's come to the reinforcement layout. I go to concrete design. We start at the beginning with the ULS. Don't calculate the SLS design situations, and want to start to reduce some calculation time only with surface 18 that's here on the top, and want to calculate So I have designed before some concrete stuff. For example, I modeling the concrete cover, and here's surface reinforcement. So I'll show you for the surface 18. I define a bottom reinforcement with diameter 8 to rebar spacing 15 centimeter, and on the top 10 to 15, and all location types on surface. So we have here what I mentioned before, this free reinforcement types. So when you choose on surface, it is really on the whole surface. Maybe I can show you here on the types for concrete design. The moment, oops, why I don't see it. Moment. I don't understand. On surface. Okay, here. Okay, so for example, here when we choose the surface 18, we want to calculate and select this. Then you see, here the reinforcement is over the whole surface, and on the bottom side here we have our 3.35, and the top side our 5.24. So I will deactivate it again, only to show you how you can control it. And yeah, okay, but then we go to the results, and I want to look at the reinforcement at first. So we have here 3 chapters: required reinforcement, provided, and not covered reinforcement. Provided is what I show you before. So, and what's interesting here is the required. So you see, okay, how much reinforcement we need. Also on the top side, and here the bottom sides. So, and theoretically you can control it with the provided reinforcement and see, okay, on which points I need more reinforcement. So, and to do this automatically, so in an easy way, we have here the not covered reinforcement. So you see directly on which points you need more reinforcement. For example, here it's only over the columns a little bit. So now we have the option, well, now we know where we must increase our reinforcement. And because it is such a little area, it would be not effective when you say, okay, increase our on surface reinforcement. So now we want to use our free reinforcement types. So normal when I well, wait, I will show you types for concrete. When I use the surface reinforcements and say free rectangular, then we can choose our new automatic function. And now you can say the parameters from, for example, from 10 to 20 millimeter diameter, and then he interpolate between these sizes what the program or what the surface needs for an reinforcement. So we say automatic, the same for the additional transverse reinforcement direction. Okay, and now we need the direction and location, say only on top side, and say 1 meter by 1 meter, and set this point here over this column. Okay, and when I say okay, oh, sorry, I don't assign a surface, so we need this 18. And when I click now OK, then will come this question because we define a new reinforcement. So the program delete all concrete design results. That's the default setting. So okay, now we can remember that over this column we need additional reinforcement, but imagine you have a bigger model and at different points, and then you don't can remember so much areas. So we have implemented a new feature. So let me delete the free rectangular again and show you in the input data under this button the global settings for the concrete design. And now you see a life cycle of results. And this is exactly the point I mentioned. If we deactivate this, then the results are not deleted, and it's a big point for modeling the reinforcement. I will show you. So okay, then let's do it again. So we save rectangular, our automatic function, okay, direction 1 meter by 1 meter, and say now okay over this column, or okay. So and now we have defined again forget. Now we have defined our free rectangular reinforcement, and you see the results of the reinforcement is still live. So that's important point. So let's do the same automatic wire copy, and oh wait, only the top side, and say here the 1 meter is perfect for us. And let's go to the other column. Okay, and now we have both free rectangular surface reinforcements and with the automatic function. And so then we need to go to the input data and activate the life cycle again. So, and then you see, okay, but now we have all points cleared with our additional reinforcement, and we can start the calculation. Okay, here is something wrong. Wait, I think I don't get the point. 18 automatic. Sorry, now we see this, but why don't see it here in this way? Let's do this also, and see here, and okay, then let's try again with the calculation. Okay, so now we see here that the automatic function calculate needed 10 millimeter diameter, and we can let it on this automatic function. But when changing the system, for example, then the automatic function will calculate and calculate again. So when we say, okay, it's enough for us, then we can copy the determined value here, and yeah, all is fine. Then we have find our final reinforcement object. Okay, so then so that's for me the first point, to check the reinforcement, the not covered reinforcement, and then you can check also the design checks, different checks for shear resistance and different things. And when all of these checks are with green light, then you're finished. So I would say customer wish was, because normal we have much more of these design checks, but there are construction rules more. They are also in the Eurocode, but yeah, a lot of customer wish that to see only the required statical sides of the reinforcement, for example. And so you can also deactivate it or activate it in the global settings. Here, the detailing and particular rules for reinforcement, and you see here a lot of points. So it's your choice, or your thing if you need it or if you don't need it. And yeah, so that's about the reinforcement layout. And yeah, then we will come to the fire resistance, and also in the global settings we are here. You can activate the fire resistance here. The default setting, the fire resistance is not activated. So yeah, click here to that you can do the options and the calculation parameters for the fire resistance. Okay, then we delete this object and switch back to the PowerPoint, to the fire resistance design. So we have activated an Rfem Secret now, and what we can do with the fire resistance design, at the time we have a table method with minimum section dimensions and rebar axis distances, and Rfem proof if these two parameters are fit for the design check. Yeah. Then what I show you about the building model, the surface with result beams. So with the shear wall, I will show you. And also for the columns, we have an additional point for the definition of fire buckling length factors. So you can calculate with normal temperature with other buckling length factor than for the fire hot calculation. It's important point. Also for columns, we have next to the table method fire duration equation, and yeah, okay, I will show you also this, and I will show you for beams. there are in the Eurocode 2 tables, one time for the statically determinate and indeterminate. So I will show you what you have to do that you get the right tables, the right checks of the right table. So okay, then let's switch back. And yeah, you see here the shear walls. Normally you don't see shear walls here. It's all because the activation of the building model add-on. So you can here define shear walls and select surfaces, and out of the surfaces the program automatically create a result beam to integrate all the forces of the model at this point. Then you can define here concrete cover, shear reinforcement, longitudinal reinforcement, and so on. I have done it before. I only want to show you the results for the fire resistance here. So let's select our shear. Our shear wall. Okay. And also the member sets for our column, and also I don't find this lead. Oh, so transparent. For this beam here. Yeah, okay. So then let's switch before we start the calculation to the fire resistance configurations. I forget to name it in English, and translated as the shear wall, and it's one side fire, so the fire exposure. So because we have different types of fire here, so we need different fire resistance configurations. Yeah, for example, for our shear wall, we have only fire from the inside of the building. For our column, we have 4 sides, so the fire comes from all sides. And for our beams, only from 3 sides, from left, right, and from bottom, because on the top side we have the surface. So you need to define different configurations. Because of these generated result beam here for this shear wall, we have implement also a criteria of classification. Is it a member, a wall slab, or a column? And the program look at the height and the width, and is there is over this definition of this the program know, okay, it's a wall, or it's only a beam. Yeah. So okay, for the columns, what I said before, we have 2 options. Here is the table method and the fire duration, and also other things for slabs, beams, and analog to this member settings are the surface options, but I don't need to show you. It's you can do it on your own way. So, but Okay, then let's start the calculation. Okay, then we want to see, also you see here an own chapter for the shear walls, and you can see here from this section properties that it is a wall, and with this wall parameters you go in these tables and you see the axis distance required and the minimum cross-sectional dimension, and yeah, that's the design check, simplified design check. Then what I told you about the columns. Here we have the options for the concrete effective length, and you also see it here. On one side we have the 1.0, and on the other hand from 1.5 to 1.7, and these are the different buckling factors for fire design. You see here is for the normal temperature, and here we can reduce the effective length according to the Eurocode, and yeah, so it's important thing to implement and use these factors. Okay, good. Then design ratios. Yeah, for the columns you see here two design checks. On the one side the table method, and on the other side the fire duration equation, and you see the differences. So both design checks are okay for the static, so you can decide. So sometimes I would say this is more effective, something this, so that you have the option to choose one, and you can deactivate the now needed design check in the configurations. Okay, then let's look for our beams. So you see it's over 100%. Maybe when we would check with literature, we say, okay, why we are over 100%? And the point is that here the table 5.5 is used, and the table 5.5 is for statically determined beams. And yeah, so why he choose the, let's say, wrong table? That's because you need to, oh come on, you need to modeling or set some points at the design supports and deflections. At the time the program see it as 13 meter long one field beam, so we need final support, and for this internal nodes we can choose this other, and I show you the difference. Yeah, I said at the start and at the end points this type, so there's no inner support, and on the internal nodes I use this inner support. So yeah, he know, okay, it's one long beam. And yeah, then you will see in a few seconds the difference. So we was on 130%. So then let's check now. And go back to design ratios for members. And now you see beams, it's 49%. And we look, okay, and before it was table 5.5. And now we see, okay, it's static interdimensional beam, so I can choose a table 5.6. And yeah, you have different values. So yeah, it's important to define this supports. Good. Then let's go to the next point. I will delete these points for better overview, and we will switch back to the PowerPoint, and now we are on theme punching shear reinforcement. So yeah, that's the pictures, and maybe I show you direct in program that's easier to understand. Okay, it was saying this point I want, yeah, the 28 notes with punching. And yeah, maybe let's start with a calculation. Okay, you see our actual reinforcement are not enough for this. And yeah, so this is the first point. When you see, oh, it's over 100%, then you can define additional surface reinforcement. Oh, wait, let's maybe see how big it should be on the top side. Okay, so 24 under 30. So let's do something in this area. So let's say 22, 15, 20. Okay, let's start with a lower. Okay, and say free rectangular. Choose here the sides 2.5 meter, and we choose it here. So it's a little bit lower, but you will see it's we give some better results. I forget here the surfaces. Okay. And yeah, let's calculate. So then you see, okay, he needs again more and more. So this point, you don't get this problem away only with additional longitudinal reinforcement. So let's see what he's done with the punching. And you say we don't need. Sorry, that should be. Maybe I do a mistake, and I choose another concrete. Let's check it. Sorry. Let's switch back to 37. Yeah, okay, yeah, sorry, then I forget to switch back to the other material. Yeah, okay. So, but now we have required punching reinforcement, and yeah, you see that he has 3 areas, different values. So let's create some punching reinforcement. I will set a new one, and here you have the options between uniform and different. And the uniform you have or on each perimeter you have the same numbers of legs, and for uniforms there's the same numbers of legs, and for different you can define on each perimeter a different number of legs. So it's yeah, but I would stay for this example for the uniform, and we'll say let's say 4 perimeters and 16 legs in each perimeter. Let's say okay, and yeah, now you see also the reinforcement, and let's say okay, we calculate again, and now okay, wonderful, we are everywhere below 100%. And the thing is, when you so you would expect that in the inner circles are okay with the 16, but on the outside perimeter Y you don't reduce the numbers of the legs, and this could be because there are also detailing checks. So the legs distances on one perimeter can be a point that you need more legs. So yeah, it's not only the numbers, it's also the detailings and member and particular rules which can make that you need more legs on a perimeter. Yeah, but okay, that's I only want to show you how you can design such punching reinforcement. Okay, that should be enough for that, and let's switch back to the next chapter, the SLS design. We will look at the deflection analysis on limitation of steel stress, and you will see we are independent from the ULS design, so we can analyze it and get required reinforcement only for SLS results. So yeah, it's a good point. And then I will show you the creep, shrinkage, and the tension stiffening effects. So if you don't know the tension stiffening, I copied a description from our homepage, so you can read this. But at the end, the tension stiffening how I say this, so or other normal way you calculate with an uncracked section or with the complete cracked section and the tension stiffening give you the possibility to use the areas which are not cracked, that you can use this stiffness and maybe I show you in the model, it's more clear then. Okay, then let's switch back to Rfem. Then let's delete this, and I want to show you the SLS design checks for the surface 30. So take this, and for the deflection, it's the first point you must control when you go to the surface. Another point, deflection. And yeah, first the surface type, you have the option to double support it, say the normal surfaces, and also cantilever. So so you must do it on a manual way. So we have here a cantilever and normal for simple surfaces that function very well. For example, this maximum and minimum boundary lines. But you see, when you choose the maximum, you have here this 14 meter, which is nonsense. And when you choose the minimum, it's 50 centimeter. I don't know where he I think here, okay, because this little area. So, but you have the option to do it on manual, and we need this from this column to the end of the surface, 3 meter 50. So yeah, you must control it for the deflection. That's very important. Okay, then when we have chosen this, then wait, I will check again that yeah, here, let's say take a small reinforcement that we see the effect on better way. Okay, and yeah, let's look at our serviceability configurations. Yeah, we have here the limitation of steel stress, and yeah, the normal case is that he use characteristic design situations, and relative new in Rfem 6 is that you can use also other design situations. For example, here quasi-permanent or frequent, and this options of individuality you have also for the moment. Yeah, you also have for the crack analysis, so you can do it individual, or also here for the deflection analysis, where is quasi-permanent the default setting. So you also can do it for frequent and characteristic. So it's a nice option to have these options too. Okay, yeah, then let's deactivate this, and I will show you then. So let's look at the limitation of steel stress at first. Okay, and start the calculation. Okay, maybe mesh and calculate it new. Okay, now I see my, sorry. Yeah, of course, we must switch back now and don't want the ULS and switch only to the SLS design situation types. Okay, sorry. Let you see that it's independent from the ULS, and you can analyze the influence of only SLS calculations better. Okay, fine. So design range is okay. You see here the stress limitation is quite over 100%, and you have here only the provided reinforcement, and so we have an option. Normal it's activated, but I want to show the difference. It's a determination of longitudinal reinforcement, and this strong feature, when I activate it, you see which points will take with for this calculation. So for example here, limitation of steel stress, and yeah, you know, before we have only the provided reinforcement, and this button, when we activate it, okay, we must calculate new, and 130% maybe, well, remember, for the steel stress. And now when I calculate it, okay, then yeah, you see 99%. And why? Because now we have not only the provided reinforcement, we have also the required and the not covered reinforcement, and this point show when you set in the required reinforcement, or better the not covered when you have it, then the steel stress can be done. So you only need to modeling this needed reinforcement. Yeah, that's a big point here. Okay, so how I show you at the begin, we could deactivate here the life cycle and put this reinforcement area for here and for here, but also, so let's say, okay, we do it with surface reinforcement, and let's say we choose automatic. Maybe let's take also 15, and okay, and calculate again. So because it's not so big, so let's do it on this way. And now we see, okay, all is green, all is perfect, how we want it. Yeah, good. Then let's come to the deflection. So we have here our quasi-permanent calculation, and we want wait, let's maybe to have it. So now we have, okay, a deflection of 8 millimeter, and now I want to show you, wait, this tension stiffening, deactivate, okay, sorry. No, Wait. Come on. Yeah, that's should not. Yeah, the 8, nothing changed, sorry. But I want to show you the tension and stiffening later. So let's take the materials and go to the materials for concrete. And now you have here a new chapter, time-dependent properties of concrete. And you see here the creep and shrinkage. And when we activate it, so remember the 8. Okay. That's default setting, so but not important for our example. And now let's go to the concrete results. And let's see how the difference is between this 8 millimeter from the statical calculation to the deflection of our concrete add-on with the creep and shrinkage effects. Okay, then we must go to the surface checks, and we see here the U, the limit is 35 millimeters, and now we have, okay, nearly 30, yeah, and so it's fit to the normal factors when you say, okay, that's the normal calculation and the calculation with creep and shrinkage, so it's a good value. And now we have the zeta, and we see, okay, the zeta is the status, I say, of cracking of the objects. And you see here, okay, it's everywhere the 1.0, so it's complete cracked section, and complete cracked with 20, okay, let's say 30. And now what I try to explain is the tension stiffening. Yeah, so you can consider the resistance of creep between the cracks. And now let's activate this. Okay, and start. So 29.6 without. And 29, and you see here it's 26. So it has the tension stiffening show his positive effects. And let's again look at this zeta value, and you see here, okay, near the columns where there is high danger for this cracks, it's nearly 1.0, but you see in the other areas it's between the uncracked and the complete cracked sections. So and this has an influence on the deformation. Yeah, so that's tangent stiffening and the creep and shrinkage effects. Okay, that should be to the SLS design checks. Then let's switch back to the PowerPoint and go to our last chapter. It's fatigue design. And I create another model, a more simplified model for you, only for understanding. So yeah, but we have two alternative fatigue design in Rfem 6. The level 1, it's a simplified design check and in the Eurocode there is a allowed stress range, and for this design check you don't allow to get over this allowed stress range. So here you see the moments, but nearly to the tensions. So the stress range is between the maximum and minimum, and this area between there is for the fatigue design very important. Okay. And the level 2, the method of damage equivalent stress range. There you can define a number of cycles. So, for example, when you have a bridge and a lot of heavy cars are over this, you can define how often this happen. So, for example, 500,000 or 3 million, and more number of cycles you have, the reduction of the material stiffness according to the Wöhler lines. More number of cycles than reductions material stiffness. So and this is possible with the level 2. Okay, then let's switch back to the Rfem 6. And let's go. Oh, I don't have a fatigue here. Okay. Yeah. Maybe let's go first to the load cases, or better to the design situations. For the level 1 fatigue design, you need the SLS frequent combinatoric for loads, load combinations. And for the level 2, you need an own combination. It's nearly the same like SLS, but here you have an additional parameter. It's this QFAT, and this QFAT is without reduction coefficients. And yeah, for this QFAT value we have implemented, you can select it for imposed loads. That's traffic. There you can choose this. You say, okay, that's a fatigue load, and out of this definitions, Rfem create a new action, and then you can say, okay, alternative, and have these loads here. Okay, then let's first maybe see the loads. Okay, that's permanent, and here the loads. Here the wind, and here is the big load, the fatigue load, I say. Okay, yeah, and so you can switch between the level 1 and level 2 in the ultimate configurations under fatigue, level 1, level 2. And when you choose level 1, then you must choose also here this design situations type, the non-cyclic and the cyclic. So level 1, level 2. Then let's start calculation for the level 1 results. Okay, then let's look what I'll tell you. And before here we have the factor for the allowed stress range from Eurocode, and here before we have an sigma maximum and minimum, and the the internal forces to this. And yeah, you see the maximum minus the minimum, and in comparison to the maximum factor, to the allowed stress range. And yeah, that's the design check. Okay, then yeah, let's go to the level 2. How I said, here the number of cycles, so 500,000, or we can also say, okay, 1, 2 million number of cycles. Okay, and then the level 2 design check. Okay, let's see here. There you see the Wöhler line calculation. So here's a 2 million number of cycles, and yeah, so nearly the same, but here that's the design check for this level 2 design check. Okay, I think we come to an end at this place. And yeah, I want to say thank you very much that you listened to this webinar. And wait, then let's go back to my PowerPoint presentation. So I will switch back to my colleague Andreas, and he will tell you about our free online services, about coming webinars, or such information stuff. And yeah, thank you. And Andreas, I give back to you the control. And yeah, goodbye.
Thank you, Richard, for this nice presentation. Some additional hints from my side. Yeah, just use our free online services on our website. For example, the GeoZone tool. Yeah, only a few clicks are for free, but you can buy click packages if you want to use it often. Then we provide a free online tool for the determination of cross-section properties. We have a large database of FAQs and knowledge base articles. You can models download from our website for free as examples for your project maybe. Then you can ask our chatbot all the time. Mia is her name. And you can write us an email to info@dlubal.com and we will help you. Okay, that's also all from my side. Thank you for your attention. Thanks to Richard for the nice presentation. I wish all a nice rest of the day. I hope we meet each other in the future webinar. Bye-bye.